This is Algebra 2, Unit 3, Lesson 3, and we're going to learn how to graph systems of inequalities in this section. This is a review of Algebra 1, but we need to be able to do this to be able to do linear programming. This is just kind of a stepping stone to that. You should have had all of this in Algebra 1. I'm going to first show you how to do these by hand, and then I'm going to show you on Desmos. Desmos will save you a great amount of time with this. Same thing with linear programming. We'll do it in Desmos. It'll be very simple, but you need to understand where the information is coming from in order to be able to do this. So the first thing I'm going to do with each of these is, if I'm graphing them by hand, I've got to get them in slope-intercept form first. So I'm going to have to get y by itself. And then I would graph this. Now, hopefully you remember from Algebra 1, when you graph an inequality, you're going to graph the line just like normal, except sometimes the line will be solid, sometimes it will be dotted, depending on what you have. This line is going to be solid because it's greater than or equal to. This one has no equal to, so it will be dotted when we get to where we're drawing that line. So let's do them one at a time here. So we've got to go up 2, and then our slope for that one is 2/3. So I go up 2, right 3, or I could have gone down 2, left 3, to get a couple different ordered pairs. And then we said already that this one is going to be a solid line. So I'm just going to draw that line as a solid line. Then the other new thing with inequalities is we have to shade either above or below that line depending on which statement is true. Now there are a couple of different ways to do this. You could pick a point that's not on the line and plug into what you have here and determine whether to shade where that point is or the opposite side of the line. If the point that you plug in ends up giving you a true statement, then that point is true and needs to be shaded. If it gives you a false statement, that point is not true and you shade the other side of the line. So giving you that example, if 0, 0 is obviously not on that line. So I'm going to plug 0 in for x and 0 in for y and see what I get. 0 is greater than or equal to 2. Is that true or false? Well, hopefully you're telling me that's false. So if this point is false, then that means I have to shade the other side of that line. Now, there is an easier way to do it. So I want to make sure I explain that to you too. This tells me that y is greater than or equal to the equation, okay? That means that y is bigger than the line, okay? Y is above the line. So I'm shading above the line, okay? That might be an easier way for you to do that one. For this one, I'm going to get y by itself. I'm going to go up to 2, and then from there I go down 3, right 4, or I could go up 3, left 4, to give me a few different points. Then graph that line. Now this one, since there is no equal to, is going to be dotted. So I'm going to go ahead and dot my line. I think it's easier, especially if you're doing it on paper, to dot it as you go rather than trying to erase what you have. Especially, and I always tell my students to use pencil, but I know some of you are stubborn and use pen, so if you're using pen, it's hard to erase, so it's probably easier to just go ahead and dot that in as you go. If you plug 0, 0 in, you would have 0 is greater than 2. That is, again, false, so I'm going to shade above. There's one way to do it. Another way to do it is y is larger, greater than the line, okay? So y is greater than the line is there. Now, we need to determine where do both of these shaded regions overlap each other, because that's the part that we want to shade for our final answer. And hopefully you're saying that, okay, this one's above the line and this one's above the line. So the section or the region where those two are both shaded is up here. So my answer is going to be this shaded region, or this corner of that graph will be shaded, because that's where both of those overlap. I want to make sure that I do at least one with some horizontal and vertical lines so that you know how to deal with horizontal and vertical. If it's y is less than 2, y equals 2 is a horizontal line at 2. So the horizontal line at 2 would be right here. It just says less than, so that one is going to be dotted. So I have a dotted line at y equals 2. And then it says y is less than 2, so that means y is below that line. So we're shading below there. I always do arrows at first because I only want to shade the region that is common to both graphs. For this one, x is greater than or equal to -3. X equals is a vertical line. So I have a vertical line, and this one is solid because it does have the equal to portion there. And it says x is greater than. Now, if it says greater than, which side is greater than that line? Well, it would be the side to the right is greater. If it had said less than, it would be to the left. So for that one, I shade to the right of that line. And then I look at my graph and determine where are both of those shaded. Well, the region where both of those are shaded is in this section. So that is going to be the shading that I use for my answer. All right, now let's throw some algebra 2 in here. This line is just a linear inequality. It's going to be just like the other examples that we did, but look at this one. It's got an absolute value in it. So we're going to use our knowledge of the parent function of the absolute value graph to help us graph this, and then we're going to determine which portion of the final graph to shade. So this is where your algebra 2 will start coming into play with this stuff. So for this one, I'm going to get y by itself. Divide by -2, that flips the inequality around. So I end up with y is less than 2x minus 5. So I go down to -5. I go up 2, right 1. Up 2, right 1. I could continue that pattern. This one is a dotted line. So I'm going to draw a dotted line as I go. And then which direction would I shade? It says y is less than. Less than is below the line, so it would be the portion that is below. And if you're not sure, because this one's, that one's a little steeper than normal, you could plug 0, 0 in and determine that 0 is less than -5 is false. So you know 0, 0 is false, so you shade the other side of the line. And then for this one, well, that is a standard absolute value, but it has been moved right 3 and down 4. Right 3, understand, is inside. It's opposite of what you would think. Down 4 on the outside. So I'm going to move this right 3 and down 4. The a value in front of my absolute value is positive, so I know it's going up. And so from this, I go up 1, right 1, up 2, right 2, up 2, right 3, up 3, and I can use symmetry for my other side. This is a dotted line again. And the side is also dotted. And then how do we determine what to shade? It says y is less than the absolute value equation. Y is less than. So we're going to shade below that line. So you might ask yourself, where do these two intersect? Well, this is a shaded region, but it's not shaded for both of them. This is shaded under the line, but not for both of them. It looks to me like the shaded region is going to be this odd shape right in here. Okay? And again, we'll do this again on Desmos so you can see that. In this example, I have two quadratics that I'm going to graph and then shade the overlapping area. So in the first one, on the top, it is in vertex form. It looks to me like the a value is 1, so we know it's going up as a normal parabola would, using the parent function shape, so it's not any wider or any more narrow than normal. For this one, it's going to go left 3 and down 2. So from my normal vertex 0, 0, I go left 3, down 2, and then I'm going to use the normal shape of a parabola. Right 1, up 1, right 2, up 4, right 3, up 9. And then I can use symmetry to get the other side. This one is dotted. So as I draw my line, I'm going to draw it dotted. And then its y is greater than. Greater than would be shaded above that parabola. So I go ahead and do everything for each individual parabola, and then I kind of combine the two together. For this one, y is less than or equal to negative x plus 5 plus 4. Well, for this one, the negative 1 tells me it's going to flip upside down. I'm going to move from the vertex, or from 0, 0, left 5, up 4. So this time I'm going left 5, up 4. And then I move right 1, down 1, right 2, down 4, right 3, down 9. And I use symmetry to get the other side. This one will be solid. A little crooked there, but it's okay. And then that one is shaded below. So where do these two overlap? Well, it looks like in this little sliver right in there. Okay, so we can use systems of equations not only for lines, but we can also use it for absolute value. We can use it for quadratics. We could also use it for square roots. That's not as common, but this is a good example of some graphing systems of inequalities. We will now do these on Desmos so that you can compare and see how much easier it is on Desmos. But it's really important for you to understand where all of this stuff is coming from as you go forward to Desmos, because later on, especially with linear programming, you have to understand how to interpret what this means. Okay, so I've got Desmos.com up here, and what we're going to do is we're just going to do these systems of inequalities on Desmos so that you can compare the answers to the ones that we did by hand. Remember to get this typewriter down here so that you can get your math symbols that you need. You click the little typewriter to show the keypad there, and you can get all the functions here that you need. And notice later we're going to do absolute value. That's right here. So it is right there on the keypad. So that makes it nice. All right, looking at the first one, the first equation was 2x minus 3y was less than or equal to -6. So there in red, or pink, I guess, is the first equation that we did. And then to put the second one in, we're just going to hit enter, go to the second row there, and this one was 3x plus 4y is greater than 8. And there it is. And now here's one bad thing about Desmos. It will not get rid of the shading that doesn't overlap. So here, if you notice, the first one that we did was in pink. So this was all shaded pink before. And then the second one was in blue. So this was all shaded kind of a light blue color. The overlap is the section that's in the darkest color. Okay, so that makes it a little bit different. When we graph them by hand, we only shaded the region that they had in common, but here they don't do that for you. So it does make it a little bit confusing, but I mean, if you know that the darkest area is what is shaded, then you should be fine there. All right, let's go to the second one. The second one was the one with the horizontal and vertical line. We had y is less than 2. And in the second one, we had x is greater than or equal to -3. So if you look, the first one is in green. Y is less than 2 is in green. And so that means all of this was shaded green before we stuck the second one in there. And then the second one was in purple. And then the deep purple here, the darkest color, is the section that is shaded. That is part of our answer. Okay. For the third example, it was 4x minus 2y is greater than 10. And they've shaded that one kind of in a gray or a black color. I hit enter, and I'm going to put that absolute value function in. So that was y is less than the absolute value. So I click this absolute value of a, and then inside where the box is, I need to click inside there and put x minus 3, and then I need to click outside of the box to put my minus 4. So it's pretty easy. It's just like a calculator. And then if you look at the shaded region, remember we had that weird shaded region. The black part was the right side here. The red part or the pink part was underneath that absolute value function, but then the overlap is this deep kind of burgundy color. It's got that little triangular shape there, and it was that very odd shape that we had graphed by hand. And we've got y is greater than, in parentheses, x plus 3. To get outside of the parentheses, we click the end parenthesis here. And then I have to square it. And then I've got a minus 2 on the outside. So there's the first parabola. Notice it is dotted. It's shaded on the inside. If I hit enter, I can go to the second one, which was y is less than or equal to negative. And then in parentheses, I have x plus 5, end parentheses, and I'm going to square it. And then I've got a plus 4. All right, so you can see there the little sliver that would be shaded the darkest region, and that's kind of what we had shaded on our notes. So you can see that Desmos does the same thing. It does it a lot quicker. I would suggest you use Desmos for this now that you know where all this stuff is coming from. You know, I like you to watch the notes, take notes on it, but then when it comes down to doing the actual work, I'm fine with you doing this stuff on Desmos because it does save you a huge amount of time.